Alright guys, my objective over here for this video is to introduce you guys to the concept of VRF Lite that allows us the ability to create virtual routers within our routing domain. My objective over here is to introduce the subject so that you have the ability to break your router down into multiple separate instances of a router within your physical router. Now, the purpose of this, there might be multiple purposes to doing that. One of the common reasons of creating a VRF or splitting your router into multiple instances of routing tables is a multi-tenant type environment where you as a company is providing IT services to multiple tenants inside the same building. Your objective is to segregate the traffic from one tenant to the other on the same router so that the two tenants don't see each other's traffic at all. So to do that, what I've done is I have set up this topology over here. I haven't fired up the routers yet in GNS, where I have two floors, floor 1 and floor 2. On the first floor, I have two tenants. Router 3, router 5 belong to two separate tenants. Let's put names over here for this. Let's call this customer A. And this site that you have on the other side on the second floor also belongs to the same customer, maybe a different office inside the second floor for the same customer. Similarly, what I have is I have another customer that is on the first floor. Let's call it customer B. My objective over here is to connect up customer B site on first floor, customer B site on second floor to each other, and A to A. The routers that connect the two floors to each other are the common routers that I manage as a company. So the links that you have in the middle of router 1, router 2, actually one belongs, let's see if we can make it as precise as possible. One of these links actually belongs, I have two links. One belongs to, what I'll do is I'll make one link belong to customer A and the other link will belong to customer B. Let's see if I can make it as concise as possible. I guess this is the best I can do. So over here I have router 1, router 2 connecting two floors to each other. On both the floors I have two customers. I want to connect customer A to customer A, customer B to customer B. One of the things that people say, why don't we use different addresses or addressing schemes and just run it on the same router? But the data plane would still flow on the same network, or even the control plane will be on the same interface. What I want to do is I want to segregate them into two different instances of a routing table. So that's my objective over here. That's what I want to show you, and this type of concept is known as VRF Lite. So how do I configure this? How do I actually get it up and running? My objective again is to connect 3 to 3, 3 to 4, and 5 to 6 through the same routers. So that's where the concept of a VRF comes in. The function of a VRF is to create a separate instance of a routing table on the same router. Alright? How do I go about doing that? How do I create the router in such a way that my traffic goes in and sits in a different routing table on router 1? Essentially what I'll be doing is this over here. I'm going to be creating a separate routing table over here for router 1 and a separate routing table over here on the same router for router 1. Actually, let me redraw that because it's also going to include this interface over here. So the routing table over here will have two interfaces. The routing table over here will have two interfaces. I'm going to run a routing protocol between this guy, this virtual router, and this router over here. Again, I'll have two virtual routers on the other side as well. So my routing protocols will talk from here to here. In order to do that, the first thing that I need to do on my router that is running the multiple instances of the routing table, the VRFs, I need to first of all create the VRF. So I'm going to create a VRF. I'm going to create a couple of VRFs on router 1. Let's call them customer A, cust A. And we'll create another VRF over here called cust B. I'll be doing the same thing on router 2 to segregate the two instances. Once I create the VRF, I need to designate which interfaces are part of the VRF. One interface can only belong to one VRF. You do have the ability to create sub-interfaces, and assign the sub-interfaces to different VRFs. Basically, wherever you assign the IP-based interface will be assigned to a particular VRF. It can only belong to one VRF. Any routes that are learned through that particular interface will be put in the VRF that the interface belongs to. So let's go ahead and take a look at how to go about doing that. So the first step that I need to do on router 1 to set this up is go ahead and set up my VRF. Step number 1 on the router that is going to be running the VRF is going to be to create the VRF. Configure the VRF on the router. Very simple command. VRF and the name. That's all I'm doing over here. We'll call it IP VRF A, IP VRF custody. That creates the VRF on the router. As soon as I do that, I have a separate routing table called cust A and cust B. Besides my normal routing table, the normal routing table is referred to as the global routing table. So let's say the two routers, router 1, router 2, I want to use for my own routing. Those type of routes will go into my global routing table, my normal routing table, the one that you look at by using the show IP route command. Once I'm done with that, the next thing that I'll be doing is assigning the interfaces to the appropriate VRFs. How do I do that? Interface, let's say F0/1, or in my case, I'll show you what my my interfaces are, F1/0. I'll set it to IP VRF forwarding cust A and no shut. Later on, I'm going to be assigning the addresses to it. Interface 1/1 IP VRF forwarding cust B. By doing this, I have actually put these two interfaces in the two different VRFs. Along the same lines, I also have my first interface that connects router 1 to router 2 for that particular VRF in cust A. So my two interfaces that are in cust A are going to be the interfaces towards R3, which is this guy. I'll write a description over here as well. Connected towards router 3, and I have this router connected towards R1 for R2, sorry, for cust A. I'll copy this over here, and this is my interface towards R4, which is my customer B router. And similarly, I'll have this. F01, which is a second interface connecting towards R2 for cust B. So basically now I have two routers with two interfaces inside each of those virtual routers. Let's go ahead and do that. Once I'm done with that, I'll assign IP addresses to it, and from that point on, most of the config is the same. Let's take a look. So I'll go and fire up these routers. I've actually created a topology, but I still need to launch them. Alright, the routers have come up. So now, what I can do is go into your terminal for it. Just launching that. While it's doing that, I'm going to go to the other one. Alright. It'll come up. I need to move this. Actually connected to 5. So 3 connects to 5 over here. I need to change this. Just cust B. Same thing needs to be done over here. So I can launch the routers first, and then we can put diagram back. Alright, so let's go ahead and take a look at this. R1 now. As I said, the first task is to create the VRF. I'll say cost A and IP VRF cost B. My two VRFs are created. The next thing is to put the interfaces in. Let me just show you the interfaces and how they're connected. I'll go to my topology summary, which is on the side over here. Let's check router 1 and router 2. F00 connects to R2 F00. This is the one that I'm going to use for cost A's link between R1 and R2. F01 is connected to R2's F01, which I'm going to use as the link between R1 and R2, between the two floors for cost B. Then I have F10, which is connected towards R3, that is the customer A router, and which is connected to R3, and F2/0, which is connected towards R5 F0/0. So this is my topology, and based on this, what I'm going to do is I'm going to create my setup. Coming back over here, another change over here. It's 2/0, not 1/1. That's towards R5. So let's set this up. So on router 1, I've created my VRFs. That was the first thing to do. The next thing is to put the interfaces into the appropriate VRFs. F00, IP VRF forwarding, cost A, no shot. F01, IP VRF forwarding, cost B, no shot. That takes care of those two interfaces as part of the links between R1 and R2, 4.1 and 4.2 in the appropriate VRFs. And now the links between R1 towards your customer router, IP VRF forwarding, cost A. The second and the third modules of GNS does have a speed and duplex mismatch if you don't do it manually. So I'm going to do it manually on F10 and F20, which is connected to cost B. Speed and duplex, you need to set it manually on these interfaces on GNS. So my router is done. Now I have three routing tables right now. I have the normal show IP route, that's my global routing table, nothing in there. I won't have any interfaces actually right now because I don't have IPs, but once I put the IPs, I will have three different routing tables. I'll have a VRF for cost A and another VRF for cost B. But you'll notice now I have three different routing tables. The global one, which is the normal show IP route, and then if I want to check the routing table for customer A, or if I want to check the routing table for customer B, I'll do it like that. Now, to move further, let's go ahead and start assigning IP addresses. I'm going to do it on this guy first so we know what type of addresses we're using. Let's say this is my first network. I'll say this network over here is 10.10.10.1 or 0/24, and I'm going to use the same thing on the other side for my link between router 1 towards the two customers. I want to keep the same networks that I own. They can have whatever networks that they have on their side, but my network towards R3 and towards R5, I'm going to keep it the same. You might say, well, how can you assign two addresses that belong to the same subnet? Because they belong to two different virtual routers. And on the other side, I'm going to say this network over here is, let's say, 10.20.20.0, and I'm going to do the same 10.20.20.0 setup on the link between 2 and 6. So that's what my objective is. Along the same lines, the links between R1 and R2, I'll say are 10.12.12.0 for both sides. You guys are okay with that? 10.10 to 10.12, 10.12 to 10.20. Good? This is all set up. So with that in mind, let's go ahead and assign the IP addresses on R1. So as we said, the first interface is F1/0. This is the interface that we said is connected description. This is connected to R3, which is customer A. All right, 10.10.10.1/24. I've already done the no shot, so it should be there. And I'm just going to finish up on this particular customer. Description, connected to router 2, also for cust A. And we agreed upon this as being 10, 12, 12, 1. No shot. So now, if I go and check my routing table, because I have IP addresses assigned to router 1's VRF cust A, you should see 2 networks in your routing table inside VRF A. There's nothing inside VRF B right now, or in the global routing table, which is show IP route. That's completely blank. So when you put an IP address on an interface that belongs to a particular VRF, it automatically shows up as a connected route for that VRF. And you can check that in your routing table. This is your first step in terms of your next step in terms of setting up your IP addresses on that router that is setting up based on VRF. Now, along the same lines, I also need to do the other VRF, so I'm going to go into F01, description, connected to R2 for cust B. I'm going to assign the same address that I assigned for the other VRF. But the thing is, it won't create a conflict because this particular interface is in the other VRF. And F2/0, description, connected to R5, which is again cust B router. And again, I'm going to use 10, 10, 10, 1. Same addresses over here. Now, if you take a look at your show IP interface brief command, you will notice that I have 2 sets of IP addresses that are identical, but it's taking it because they are inside different VRFs. Alright? So to complete this topology, I now need to go to router 3. I need to go to, let me just close this one because I just need to go to router 3 and complete it. On router 3, he's completely unaware that there is a concept of a VRF. He's just treating it normally. So over here, it's just an F00 interface. IP address, it has to be on the 10, 10, 10 network. I'll give it an IP address of 3. Because of that speed and duplex mismatch concept of that GNS interface, I need to set it up manually. I did. This router has no idea I'm going through the VRF, or I'm connected to a router that is running my interface in a VRF. So I'm going to do a normal thing. I'm going to create another loopback over here. Let's say 10.3.3.3. Simulate a network. Let's say LAN behind the customer router. And I want to run a routing protocol. Let's run EIGRP. Normally, I'm going to say network 10. That takes care of both my network 10s. Good. Similarly, I'll do 5, which is also unaware that he's going through a VRF. Speed, duplex, no shot, create a loopback. Let's create this as 10.5.5.5. And this guy over here, I'm going to run OSPF, just so that you guys see that I do have the ability. How do I run different routing protocols inside the VRF? Over here, I'm going to say network 10. That will include all the interfaces in area 0. So my customer router side is done as well. Can he ping? He should also be able to ping 10.10.10.1, which is the centralized IT department's IP address on router 1. Good. Now, let's complete the IP address setting. We've done it so far. If you take a look at it, our configuration is right now complete on this link. This guy is talking to this guy. This guy is talking to that guy. Now the next thing to do is complete this link. I've done the link from R1. I need to complete the link on R2. Once I'm done with that, I'm going to do the link between 2 and 4 and 2 and 6, the IP addressing on it. Once I'm done with that, we're going to run the routing protocol. As we decided, I'm going to run EIGRP over here between R3 and R4, and I'm going to run OSPF between 5 and 6. Cool? So with that in mind, let's go ahead and get started. Let's finish the IP addressing first. Let's do the same things that we did on R1 on R2 for these two interfaces. Let's take a look. R2 again, it has not been configured, so I'll start it from scratch. I need to create the VRFs first. So my two VRFs are done. I need to assign the VRFs to the appropriate interfaces. This is the interface connecting to description, connected to R1 for cost A, IP VRF forwarding, cost A, no shut. F01 is connected to cost B for R1, IP VRF forwarding, cost B. Now that we know what to do in terms of IP addresses, let's go ahead and assign the IP addresses as well and see if I can ping it. IP address 10.12.12.2. That's the link between R1 and R2 for cost A. And on the other interface, I'm going to do the same IP. So now if I take a look at it, I should be able to ping from R2 to R1. But if I do 10.12.12.1, the normal ping uses the global routing table for pinging it. But there's nothing in the global routing table. I have configured these IP addresses in the VRFs. So if I want to use the VRF table to send my pings, I need to qualify my ping by saying VRF cost A. Look in the cost A routing table for 10.12 and ping it. So it's going to send it over the appropriate interface. First checks the routing table and sends it over the appropriate interface, which is going to be the top interface. And the same address exists on router 1 for cost B, so I can do cost B as well. Alright. Similarly, if I was on R1, I need to ping 10.10.10.3, which is in cost A. I would do this. If I wanted to ping 10.10.10.5, which is in cost B, I would do that. R2 is done. Now R2, the other interface connecting towards your cost A router, which is R4 and R6 for cost B. Let's do that interface, F1/0, IP VRF, I'll give it a description as well. Description, connected to R4, which is cost A, IP VRF forwarding, cost A. IP address will say 10.20.20.2, because that's what we agreed upon. This is that F10 interface. So the duplex and speed manually needs to be set up. Then my second interface connected to R6, cost B, IP VRF forwarding, cost B, IP address 10.20.20.6, speed, duplex, no shut. Now let's take a look and see our routing tables for VRF cost A. Two interfaces, and for B I have two interfaces. Same two, but on two different routing tables. My normal routing table is empty right now because all the interfaces I've assigned to my the two VRFs. So let's finish up on the config of 4 and 6. 4 again is completely unaware of this is happening, so he'll just go in and set the IP addresses normally. 10.20.20.4, speed and duplex because the other guy has an issue. Loop back 10. Let's create 10.2.2 over here on both sides. Router EIGRP 100. No auto, network 10. That's R4. Should be able to ping 10.20.20.2. Good. Now this guy over here. IP address 10.20.20.6. Actually, I made a mistake. This should be 10.20.22. Did I say 6? Yeah. Good. Because this guy is 6. Speed, duplex, and no shut. Create the loopback. I'm also going to create this as 10.2 loop. So I can create a conflict. Router ID 6.6.6.6 network 10 0 0 0 0.255.255.255.0 show IP route. Show me my 2 routes. Should I be able to ping? Should be able to ping. Good. So my setup is complete in terms of IPs. Now the next stage starts. So let's just complete our document over here. So this part is done. I've just added the speed and duplex. That depends on the type of interface that you're running. Speed and my duplex setting, I've set it manually to full duplex. I've done that on my interfaces that require it. In my case, it doesn't necessarily have to be in your case. Now this is done. I'm not going to configure or show you the config of the normal router. I'm pretty sure you know how to do that. My objective over here now is to show you the routing protocol. Configure the routing protocol inside the VRF. Alright, how do I do that? We've already configured the router on the customer side. How do I configure the routing protocol on the VRF? Let's talk about EIGRP first. In EIGRP, when I configure EIGRP, if I do a normal EIGRP config, for example, I go in over here, say router EIGRP 100, and I press enter. This, whatever I do under here, will be done for the global routing table, unless I do it for that particular VRF. So what I generally do, I just use an EIGRP 1 as a separate autonomous system. That is where I'll configure multiple customers if I have multiple customers using the different VRFs. Anything that you do over here will be done specifically for the global routing table. So I need to run EIGRP with R3 and with R2 inside the VRF. The way I do that is, first thing that I do is I go into the address family for VRF. So basically this command is putting you into an address family that is specific to this particular VRF called cust. Now whatever you do, including autonomous system, is set up for cust. If I had done my network statement, no auto summary, those type of things inside EIGRP 1, that would be for my global routing table, because I want to run the routing protocol specifically for interfaces that belong to cust. I would need to do it under the address family cust. So that's where I do it. So first thing that I do over here is specify my autonomous system, which needs to match the other side. I'm using 100, the normal no auto summary, and then my network statements. In my case, just network 10 would be good enough. As soon as I do that, you should see a neighbor relationship come up. So my neighbor relationship with R3 is done. Okay? How come? Because R3 had already configured with OSPF in AS100. Notice I am getting that route. And to complete this, I'll go to router 2 and do the same exact thing. Router EIGRP, this number is for the global routing table, so it's irrelevant. What needs to match is a router autonomous system that you do under the address family for VRF cust. So that is this one. This needs to match all the neighbors over here. All the summary. Network 10. That includes both 1012 and 1020. And my neighbor relationship with 1012 is done. If I look at my routing table now for cust A, I am learning the 10.3 route now. And not only that, I'm also learning the 10.2 route from router 4. Why? I had already run EIGRP. Because of that, R3 over here should also be learning the route from router 4, which is 10.2. The other side is 10.2 for both cust A and cust B. I did that purposely to make sure that you know, even if I have the same 10.2, I am going to the appropriate device. If I do 10.2.2.2, I am actually going to router 4, not to router 6, because it's going through that VRF. So the path it's taking in your diagram, let's follow the diagram over here. The path it's taking is over here. the packet comes in into what interface? The interface that belongs to VRF cast A. So it checks that particular routing table and exits from the interface that is also defined in that routing table, which is F00. And because of the two different interfaces, it either exits from F00, he receives it from F00 because he's receiving it off the interface that is part of cast B, cast A. It will look in the routing table for cast A and forward the packet to this guy. Because the incoming interface over here is F1/0, which belongs to cast A. It checks a routing table for cast A, the VRF for cast A, where it sees, if you take a look at it, I can show you that as well. If you take a look at it, if you take a look at the routing table over here, show IP route, VRF cast A, you will notice that 10.2 is reachable via F00. So that's why it exits from F00. Because it exits from F00, which is connected to the F00 of R2, it enters into R2 from F00, hence it checks again the cast A routing table. So the routing table it checks depends on the interface that receives the packet. If the packet comes in from a particular interface, it checks the appropriate VRF for the routing of that packet. So right now I have communication from R3 to R4. To write this down in our notes section over here, how do I run EIGRP on the router that's running the VRF? Router EIGRP X. This AS number doesn't matter. This is the one that will be used or can be used for the EIGRP process for the global routing table. Alright. Once I do that, inside here I do the address family, IPv4, VRF, cast A. As soon as I do that, any command from this point on, the normal EIGRP commands from this point on will affect cast A. So the first thing that I do over here is specify my autonomous system number, which has to match the other neighbor, no auto summary, and the network statement. Cool. So I'm not running it on the other VRF, I'm running it for this particular VRF. So that's how I tell under EIGRP what VRF to run it for. Actually, I'll take this out and put it as a separate note. XX is the process that can be used for the global routing. Alright, clear. How do I do OSPF now? Let's take a look at OSPF. OSPF is a little different. It segregates the VRS by process IDs. So for OSPF, I say router OSPF. What I generally do is I keep one for maybe running it to the global routing table. I start with process ID 2, link it up to VRF cast 3. So it's a little different. You don't need to do the address family IPv4 VRF. You just do it right under the router OSPF process. You specify I'm running it for cast 3. And from that point on, it'll be normal stuff. 10.0.0.0, 0255, area 0. The reason, the way you know it's for what? That particular VRF, because you wrote that in the routing process. Right? In R2, I'll do the same thing. Router OSPF2, VRF, cast B, router ID, let's say 2222, network 10.0.0.0, 0.255.255.255.0, network. So now I have set it up. Show IP route. So now I have the 10.2 network. I should also get 10.1. First step is a little slower, or oh no, I'm getting 10.12. I should get the other network, which is 10.5. Something wrong with 10.5. 10.5 is there. That's strange. Two and 10.5. There you go. It took some time, but eventually propagated 10.2. So now on R5 I can ping 10.2.2. Or from R6 I should be able to ping 10.555. So how did I run OSPF over here? Router OSPF X, any number, VRF cost B, then normal stuff, router ID 6666 or 2222, whatever, no actually 2222, because that's the router that I'm running with the VRF, normal advertisement of OSPF, and I'm done. Alright, this is a simple VRF Lite configuration. You can see over here the main things that I wanted you guys to see is how do you segregate a router into virtual routing tables, then how do you assign interfaces to those routing tables. The interface is very important because the interfaces define what routes go into that particular VRF, and then how to run different type of routing protocols. I showed you the two common ones, EIGRP, OSPF inside that VRF. Alright, I hope you enjoyed it. Good luck, and I'll be posting more videos like this.